Okay, so today we're going to talk about the second part of our unit, which is using objects, some classes that we already have that are given to us by Java, and how to use them. Now, this piece of this isn't quite correct. We're going to just discuss classes within Java that we are going to use. All right, so we have libraries and packages. These are how our classes are organized. Packages are organized groups of classes. We want to use these things because if somebody's already written them, we might as well just use them instead of rewrite them ourselves. So these are all located in different sorts of packages, and they're all organized. And the libraries are sets of packages that can be imported into our code as jar files. We use the ones that are given to us by Java, but there are also other ones that we could use, like someone else might write code and we might use that code, or we might even organize our stuff into packages. There are some jar files that I have that we can use. They mostly have stuff with graphics in them, but for right now, all we need to worry about is that the packages we are using are located in the Java download. Okay, so here's the package, Java, and there are other packages below. Lang, util, auth. Okay, these are different things that Java has. And these are the classes at the bottom, and the packages are here. Okay, so what's the library? The Java library is where all of these packages are held. It's included in our JDK download, so we don't need to add any more jar files to our projects. This is our library, so I should get rid of this. This one's our library. And this below, these are our packages, lang, util, and auth. Now, how do I use the libraries? So if we want to use them, some of them we need to import. It happens at the very top of the class, so at the very beginning of the class. And for instance, we use them when we're using the ArrayList class, which we'll be using a lot in this class. Now, the ArrayList class is located under util, so I'm going to write ArrayList. So that's where it's organized. Okay. And so when we want to use it, we use our import statements here at the top. So we could say import java.util or import java.util.ArrayList. This one is importing the package. See, this is the package, the util package. And this one is importing the class. Notice the difference in syntax. So this one, java.util.star, it's importing everything in the package. So I could use I can use the ArrayList class, I can use the scanner class, I believe was in there also, let's see. The scanner class, anything else that's in this util class, if I say util.star, I'm getting everything in there, so I don't need to write multiple import statements. If I just use java.util.ArrayList, I only have access to that class. Now, this is an important note. Anything in Java's lang class, that one, we don't need any imports for. So, we're talking system, we're talking string, there's other things that are in there, but those are the two that we've used, the system.out.println or string class. We've never run into any errors because they're included in the package for us. No import statements needed. Now, an API, it stands for Application Programming Interface, okay, and they're pretty useful in programming. So they're organized by packages and classes. They give us outlines of what our classes have that we're using, how they're constructed, and what their methods are doing. So they don't list any of the code, but they just tell us how things work so we can use them correctly. So if we are looking at, this is one for the string class. And so if we're looking at the string class, I just took a snapshot of what the method piece of it. I skipped the constructor and any of the constants or variables. So here you can see this says char. That here is a return type. Here's char at, that's the method name. Here, char at is the method name, but this here are the parameters. So we know what we need to give these methods when we use them. And this here, under description, is what it does. So it's a lot of useful information. Now, where can I find these? Well, you can just click, or just Google search, Scanner API Java, Math API Java, all of these things. I have also attached them here so you can click on the actual slideshow. Okay, and then this brought me to the math class. So see, this gave me some, these are some variables that I'm going to use. Here are some methods that I might use. And again, we'll talk about static in a minute, but these are all return types. Okay, these are the names and the parameters. So ABS, what does this do? Returns the absolute value of a double value. So it takes a double. So I could say ABS -5, and it's going to give me 5. We'll talk about how to call this in a minute. Now, if you want to create your own API, it is not required at all, but some people want to learn how to do it. You can click here. And it takes us to a place in Oracle that gives us a Java.doc tool. You use Java.doc comments, so they're very specific comments. They are listed. Here's an example. This one makes it a little bit easier. All of these, see how it's usually, if we're doing multi-line comments, right, we'll just do \** star \* to end it. Now, \* star means Java.doc comments. It means I'm going to create an API. Okay, it looks like this returns an image object, so this is telling what it does. It's giving a little intro, and it's saying exactly what we need, and it has different coding in it. So if you would like to, I think this is HTML coding, if you would like to use it, it says @param, it's giving us the parameters. Let's see if they have what it looks like. Down here. If you'd like to use it, you can. I think I skipped. This says public image, get image, URL, string, name. And so it's showing us what it's going to look like with get image. There's some simple examples here that you can follow as well. Now, again, this is not required, but if you want to do it, feel free. Okay. So let's get into the meat of things. The string class is going to be very important to us. Strings, we've already talked about, they're like words. They're a sequence of characters, so more than one char. And they are enclosed in quotation marks, like this. Can't have them without quotation marks. Which they themselves are not a part of the string. It's just telling the computer we're going to get a string here. They're objects, so they have methods. And they also have references, which are important. Okay? So they're somewhere in the computer where they can find them. We'll talk about why that's so important in a minute. We've talked about concatenation. It's the basically like adding two things together, adding two strings together, okay? Where we are going to use the plus operator with this. And you can see in the example, we have one string called A that says I love, another string called B that says my APCS class. If we assigned it to A string becomes A plus B. Now, this should say A string is I love my APCS class. If you connect a double or an int or a char to a string, so you have a string that's there and you connect a double, an int, or a char, it will automatically change that double, that int, that char into a string in order to have the string go together fully. So Strings have indices. This is very, very, very important. They start at 0 here. And then each spot in the string has a number assigned to it. If there was a space, that gets 1, 2. Okay, in this case, we have the word the, starts at 0, ends at 2. It will always start at 0 and end at 1 less than the length. So, this is the end. That's always true, and this is going to be very, very important. We use it a lot, especially during loops, when we use loops. Here are some of its built-in skills. We have length, which gives its length. We have char at, and we need an integer there, which gives us the char to give an index. Index of a specific char or a string, okay? That's going to give us an index. We're going to put in like some sort of char, and it's going to give an index, but if it's not there, like, let's say, well, we'll do an example in a minute, but if it's not there, it'll give -1. And then substring. There's substring with 1 int value, substring with 2 int values. The substring with 1 int value gives you the substring it gives you a string from the starting index to the end. The second one gives you the starting from this starting point to 1 less than the ending point. So the bounds of these are very important. Okay. If we look at a name, Kathy, the length of the name is 0, 1, 2, 3, 4, 5. So this would give us 5. The char at 2, I always go like this, 0, 1, 2, 3, 4. The char at 2 is T. What is the index of B? There is no B, so we get -1. What is the index of A? Well, that is at 1, 0, 1. What is the index of at? It's going to give us the starting index, so again, that's going to give us 1. What's the substring from 3 on? It's HY. And what is the substring from 2 to 4? So 2 would give us 2, and then it's going to stop 1 before 4, so TH. So this is how we use this. Now notice, these things are saved with the same type. So this thing, length, was going to give me an integer, so it's saved as an int. Char is going to give me a char, so saved there. Be careful, even if you use substring, substring gives me a string. So even if it gives me 1 letter, it's saved as a string and I need to save it as such. In this case, it gave me 2. But you can use it to give you 1 letter. You still need to save it as a string. Again, notice because B was not in the string, we got -1. Now, this is kind of weird, right? We have 2 methods that had 2 of the same name. Substring, and index of, and index of. Again, we talked about this. This is called an overloaded method, all right? Overloaded method means they have the same name, but their parameters are different, and they're overloaded. So here, even though they have the same name, they have different parameters. This only has 1 int. This has 2 ints. This only has 1 char. This has 1 string. You could also have another one where it was like the parameters are in a different order. Their types are in a different order. That would be okay also. Because the computer is very specific. It looks for the number, it looks for the type, and it looks for the order specifically of the parameters. So, there are also 2 ways that we create a string, okay? One is using the new keyword and the constructor, and the other is called a string literal, which is just using the equal sign. Now, to be clear, this is very, very, very important. Only strings have a shortcut like this. All other objects have to use the new operator like we have been using. Only strings can do this. But we also want to be careful when we do this because there's a specific thing happening in the computer when we want to do this. Okay? So, the one with just the equal sign is called a string literal. And then this is just a regular old string when we're using the keyword new. Now, string literals. Okay? It's contained in double quotes. We can use it like we have been using here in system.out.print, hello, or we can use them to create, and we just use becomes or the equal sign here. So these are the two times we're going to see it. Now, there is a difference, and it's an important difference that you're going to need to know. String literals, when they're created, all other occurrences of that string with this, when it's created as a string literal, will point to the same object. Okay, so if they have the same value, they point to the same object. Same value meaning its contents are the same. Why is that important? Well, it's important because we need to know how many references there are. How many objects are there? It's really important. All other further occurrences of the word hello here, they refer to the same object. So you can see these are two different pointers. They're two different variables. We have M1 and M2, but they both point to one object. These are also referred to as aliases because they point to the same thing. So I'm going to write that here. M1 and M2 are aliases. Okay. So, what's the difference with a string literal? Okay? So, we can see that these two point to the same one, like we just talked about. M1 and M2 are aliases. They both point to the same object. Here, we had student 1 and student 2. They both point to different objects. Even though they hold the same content, they still point to different objects. Why is that? Because these are created with the new operator. There's two different objects. Now, again, the only object that is going to use this string literal creation, like this with just the equal sign, is going to be strings. So, now, when we use constructors, when we use the constructors here, even though we have the same contents, because we use the new operator, there's two objects, even though they have the same contents. S2 and S3 are not aliases of each other, okay? Have, I should say, two different objects, even though they have the same contents. That's because we use the new operator. So, literals versus non-literals. They're both strings. They both have access to all the methods of the string class, but the compiler views their references. The way the compiler uses their references can cause some confusions with comparisons. And this is why this is really important. So, where do they point? We can see that S4 and S5 are created using string literals. They are both string literals. I should say string literal creation. Therefore, they are the same string. They point to the same string. You can see that here. Now, S6, even though it has the same contents, because we used the new operator, this is a whole different object. Now, you all have not seen this equals equals right now. What does equals equals mean? Well, equals equals is a way to compare. So it's saying, is this true? Okay, so, and in this case, when we use equals equals, it's comparing references. So it's asking, literally, is it the same object? So S4 and S5, is it the same object? They return a Boolean, or the equals equals gives you a Boolean. So, are S4 and S5 the same object? Here they are. Yeah, they are the same object, okay? Are S4 and S6 the same object? No, they are not the same object. They have the same contents, but they're not the same object, so this is going to give me a false. Same thing with S5 and S6. So when we compare strings, oftentimes we want to avoid using equals equals. Instead, we use dot equals. Dot equals ignore case, which is just what you think it is. It's going to ignore the case. And compare to. Okay, they all return, well, two of them return Booleans. These two give us Booleans. And this one gives us an int. Okay, so what does that mean? Dot equals an ignore case. It compares the contents of the string. So this is comparing contents. So does compare to, actually. Compare contents. So, if I have hello and hello, lowercase hello, capital hello, and another lowercase hello, okay? Does S1 dot equals, and we put the second string in here. So does S1 dot equal S2? No, they do not. They're not the same. They're not exactly the same because one has an uppercase and one has a lowercase. Okay, what about these two, S2 and S1? No, it doesn't matter which way you put it. They're still not the same. Okay, what about if we say S1 dot equals ignore case? So we're ignoring the case. S2, yes, it does. Return true. S1 dot equals S3, yes, these have the same contents, and the other way around, S3 dot equals S1. Okay, so I'm going to do equals versus equals equals. So if I have S1 becomes hello, new hello, S3 becomes new hello, okay? Remember, dot equals is comparing contents. These have the same contents, so it's true. Equals equals is comparing reference, and since we used the new operator here, these have different references. Since they have different references, they're different objects, and it will return, or it will give you, false. Generally speaking, we like to use dot equals, ignore case, and compare to. Okay, so let's talk about compare to. When we talk about compare to, we're looking at what does it give us, what's its return type, it's an int here, and how is it comparing the strings, okay? So, it compares them in lexicographical order, okay? What is that? That's kind of a big word. What does that mean? Talk about it in a minute. But what you need to know is if one precedes, which means comes before, if S1 comes before S2, I'm going to get a negative integer. If they're the same, I'm going to get 0. If S2 comes before S1, I get a positive integer. I have a kind of a shortcut way, the way I think about it, which I'll show you in a minute. So, Lexicographical ordering, what is that? Okay, it's what position are we on the ASCII chart. So, digits come first, then capital letters, then lowercase letters. So, how does it work? If S1 comes after S2, then it's greater than 0. So it's going to return an integer greater than 0. The way I think about it is like this. S1 minus S2. If this one comes later, if S1 comes later, I'm going to get a positive. If S1 minus S2, if it's the same, I'm going to get 0. If S1 minus S2, so now if this one comes later, then I'm going to get a negative number. Okay, so I think of it in terms of subtraction. It kind of helps my brain a little bit. So let's look at an example. So I have Minnie Mouse and Mickey Mouse. Now, the other thing is it goes down the line with the letters. So it's going to stop once it finds a different letter. If it never stops and they're the same letter, we're going to get 0. All right? So let's look at Minnie Mouse and Mickey Mouse. First, it looks at the M. No, that's not going to work. Then it looks at the I. No, it's not going to work. So it's going to compare the N and the C. Okay? So C comes before N. So if I said S1 minus S2, okay, this one is smaller because it comes before, because its ASCII code is smaller, and so I'm going to get a positive. Okay, now let's look at these. Compared this one, no. Compared this one, no. Okay, well now I have these. Now, but remember, capital N is going to come before lowercase c. So now, S1 minus S2, I have early minus late. Okay, in ASCII code. Well, now that's going to give me a negative number because this one is smaller. N is smaller. No, it's a smaller number than C. Okay? And now if I have Minnie Mouse and Minnie Mouse, it literally goes through every single one of these like this. Oh, hey, wait, look. Even the space, they're all the same, so it returns 0.